Good evening, everybody. Welcome back to another vBrownBag. Tonight, we are continuing our series, new technologies you need to learn, skills you need to keep your career up to date. Today's topic is going to be serverless is pragmatic, CICD in the age of infrastructure as code, delivered to us by Chase Douglas. Before we dive into that, though, a few housekeeping notes. We are doing this show live on Zoom. You can join us if you happen to be watching this on YouTube. We have many show times. This is the US show every Wednesday at 7:30 p.m. Central, but we have many other shows as well. If you're watching this live, feel free to join in the conversation. Please use the Zoom Q&A or just tweet at us using the hashtag vBrownBag. If you are watching this after the fact on YouTube, now you know how to get involved. Check out vbrownbag.com/brownbags to get in on any of these. And if you're watching live and you didn't know about our YouTube channel, go check it out, youtube.com/vbrownbag. If you are enjoying this and you feel like you have something you want to share with the community, reach out to us at any time. You can tweet at vBrownBag. You can tweet at me, Ken Nalbone. I won't speak for every one of the vBrownBag hosts, but my DMs are open. And if you want to reach me, that's an excellent way to do so. But without further ado, we are going to move on now. I'd like to introduce Chase Douglas. He is going to tell us all about serverless in the age of CICD. I'm going to stop sharing my screen, Chase, and hand it over to you.
Awesome. Let me get my screen shared here.
Okay.
And away we go.
All right.
I'm really excited to be here. Thanks, Ken, and to the whole vBrownBag community. And I'm here to talk about this extremely jargony, acronym-filled set of concepts. And it's all about how teams and organizations build and deliver modern applications. So the way that people are moving towards doing that is through serverless approaches. But once you start adopting serverless approaches, it means you really have to adopt a bunch of different approaches to go along with it around CI/CD and infrastructure as code. So that's what we're going to focus on here today. It's not extremely specific to serverless. It's more just about, as you're building modern applications, what does it mean to collaborate and deliver those together across disciplines, across teams within an organization? So my name is Chase Douglas. I'm the CTO and founder at Stackery. I'm an AWS serverless hero, yada, yada. That's me. But I also want to call out my colleague, Anna Spies. We both worked on putting this presentation together. Sometimes we give it together, sometimes we give it independently. But I thought it was only fair to mention her as well. She's one of our awesome engineers here at Stackery. And let's dive into it. As Chris kind of needled me on Twitter a couple of days ago, it's an extremely acronym-filled, jargony talk title I have here. So I promise we go through all the acronyms, and we'll start with just the basic, what words do these acronyms stand for? If you're not familiar with CI/CD and IaC, we're talking about CI is continuous integration. CD is continuous delivery or deployment. And IaC is infrastructure as code. So you may have heard of some of these terms before. Don't worry too much, though, because we're going to start to define these terms and talk about what they mean as you build and deliver modern applications. So let's start with the last term, IaC, infrastructure as code. When we're talking about infrastructure, honestly, we're talking about a fancy word for the computer hardware, software, networking equipment that allows web and other applications to run. This kind of stuff that you've seen in data centers. Managing this infrastructure, though, can be hard. So infrastructure as code was born as a way to help manage all of this infrastructure in a more comprehensive way. So as an analogy for any musicians out there, if infrastructure was a modular synthesizer full of patch cables that you have to connect together in the right way, infrastructure as code is your sheet music guiding a MIDI keyboard. Everything is written down and can be automated. And changes can be documented and versioned in files. So now that we understand a little bit about what conceptually infrastructure as code means, how does CI/CD fit into this? Well, mainly infrastructure as code has really enabled CI and CD to take off in terms of how you can manage your infrastructure alongside your source code as it's being built and shipped and deployed out to customers. So let's explain. Again, when we talk about continuous integration, it's useful for us to define this a bit further. Continuous integration involves how you take your source code for your applications, your business logic, that's typically shared inside of a Git repository, and how you integrate and test that at a base level on its way out towards a deployment. So you can think of some of these processes as a relay race, but there are multiple batons for the same team. And in one sense, it kind of also never ends because you continuously deploy changes as you make them day by day, or even hour by hour, minute by minute. And by the way, before the next runner can accept the baton, continuous integration in one sense is what ensures that your linter has to say check your source code. It's some of your testing processes that you do as you're packaging on its way to shipping. Although we're not talking about this kind of linting, unfortunately. We're talking more about these kind of linting, checking your source code for, say, syntax errors. Continuous delivery, the CD part of CI/CD, is how that integrated code that's been built and checked ends up getting deployed out into various environments on its way out to production. So if code is merged multiple times a day, you really want to deploy these changes out to your users as quickly as possible every time a change is merged into your code base. So the trick is to continuously deliver the software in a safe and reliable way, kind of like a German train system, always on time. Serverless fits into this because it depends on infrastructure as code. As you are building serverless applications, you're building all of these extremely tiny microservices that have to coordinate together. And the only way to sanely deploy a serverless infrastructure is using infrastructure as code, because a given service in your platform, maybe it's your billing service, is likely to have a dozen or more functions, a dozen or more queues, with additional queues for dead letter processes, potentially services or resources to help send notifications about billing changes out and integrate with other APIs. So you end up with a huge graph of resources that have to work together. And the only way to sanely manage that is through infrastructure as code. So serverless and infrastructure as code go hand in hand. But again, kind of like our modular synth that we were looking at a little bit ago, this stuff gets very complex very quickly. So let's start looking at not only, assuming that we've got this complexity of how things are pieced together, that's like a technical complexity. There's also some challenges inherent in how organizations approach this problem. Especially, let's take a look before infrastructure as code even existed in the first place. For a long time before infrastructure as code, as we were still building and shipping applications, web applications, before or even after we started to use cloud environments, there was, for better or worse, a bit of a divide between operations and development teams. Typically, infrastructure to provision applications onto would be requested by development teams as they were building out new applications. And then operations teams would have to provision that. It would take, especially for data centers, could take weeks or months to get all that hardware provisioned. And then even once that hardware is provisioned, the developers oftentimes needed the operations team to help them deploy the applications that they built into those servers in the data center, or potentially the virtual machines in a cloud environment. Unfortunately, this divide ended up creating some gatekeeping scenarios on both sides, where knowledge sharing across the organization, the engineering organization, between ops and devs started to break down. This caused a bunch of problems. One is that there could be a lack of standardization for some of these processes. The best practices on either the dev or the operations side weren't always being shared, so they weren't always documented. They could be overly reliant on one engineer's approach, or maybe each engineer had their own standards and approach. And this made onboarding new team members very difficult. On top of that, before infrastructure as code, manually provisioning and then eventually tearing down infrastructure can require a lot of work that each person on an operations team would have to carry out. So it was slow and prone to bottlenecks. Further, there could be conflicts. What if different teams requested different kinds of equipment and you had to figure out how to share it? What if the correct infrastructure wasn't provisioned in time for a feature launch? All kinds of infrastructure-related conflicts were very common before infrastructure as code. And all these things tended to slow things down. You had very slow update cycles for applications. It's hard to move fast when you're waiting on others. And that means features and bug fixes can be held up for long periods of time. And even after you get things pushed out the door, if you're doing everything manually, and then you find that you need to roll things back, it can be very complicated and error-prone. Rolling back to a previous version requires more manual steps, and oftentimes these aren't documented because everyone just assumes that everything will go out correctly and appropriately the first time and never need to be rolled back. So then along came infrastructure as code, and it didn't necessarily solve all the problems on its own, but it was a game changer. And the problems that it doesn't solve, it still provided pathways towards resolution. As I mentioned previously, infrastructure as code and serverless, they're best friends. Combined, they bring a host of solutions to the challenges of infrastructure management. And once we start to adopt infrastructure as code through some techniques that we'll get into, we've got the ability to break down this barrier between development teams and operation teams, which really helps to solidify this movement towards DevOps, where you have a practice of people who are working together towards shared common goals across the developer and operations divides. Oftentimes we see this in practice once these barriers start to break down, where operations engineers help application development engineers learn and develop deployment strategies. Those application engineers as well start to learn about infrastructure management and infrastructure as code, especially once they start to adopt serverless and other cloud-native modern practices. And that means that the developers can now provision their own infrastructure. The code changes, because of infrastructure as code, are now deployed by the development teams through cicd. And that means that those who write the code are now the deployers of the code. And this is where you get some of that realization of DevOps through the entire chain of software development through to delivery. So you have a lot of knowledge sharing that occurs once you start to break down these barriers between the application development teams and the operations teams. In fact, oftentimes you see the operations teams coming in with their expertise and helping the developers understand how to do infrastructure as code. You often, as well, see knowledge sharing going the other way as well, where application development teams are able to, through the infrastructure as code and the management of infrastructure, help the operations teams understand more about how their applications operate. So that whenever there are problems, whether it's outages or other potential production issues, everyone can work off of the same page towards resolution. And that's what standardization helps provide, that shared page, that shared understanding of how a system works. Because these best practices are built in and implemented in infrastructure as code templates that everyone now can understand. It also means that it's easier to onboard new team members because everyone can point to the same mechanism used to manage infrastructure and deploy out. We get benefit as well of automating the provisioning and tearing down of infrastructure. That infrastructure is defined in a template file, and adding new resources and tearing them down is as easy as pushing new versions of that template. Conflict resolution is easier as well. The conflicts that we might have in infrastructure as code tend to be resolved at merge time for a pull request, using techniques that we're all familiar with as software engineers when we understand and learn about Git workflows. It means deployments are much faster to update. There's no need to wait on other teams to get you your infrastructure, and bug fixes can be deployed immediately as soon as an application development team has a resolution. And if you do hit issues once something has been rolled out to production, infrastructure as code provides reliable ways to roll back changes. Simply check out a previous version of your code base and deploy that out. Version control allows you to roll back very easily. So now that we know the what and why of infrastructure as code in modern serverless architectures, why don't we take a look at an example story of how a team ends up adopting infrastructure as code and CI/CD. So for the rest of this presentation, we're going to introduce a startup that is working hard to implement infrastructure as code. We're going to follow them on their journey into serverless application development and delivery. So meet the Noisy Herd team. This is the team, and definitely not the result of a Google image search for startup team stock photo. They run a virtual event platform, and they're very busy these days. They also are pragmatic. They want to focus on making the best event platform and not on the intricacies of infrastructure operations or container orchestration. So they went with a serverless approach using infrastructure as code. So why did they go with a serverless architecture for their application? Well, events are bursty workloads by definition. They happen at specific points in time, and then they're not happening. They may be happening just 9 to 5 on 1 week out of a year for a given conference. And so a serverless solution helps to scale up quickly when you need it, and then scale down when events aren't occurring. Serverless allowed the team to define an architecture of managed services so that they had to deal less operationally with how these services ran. And they defined them using infrastructure as code in version control. And it gave them an ability to choose the managed services that they needed to build the video streaming platform that they needed. So for example, they were able to use something like AWS Media Live for their video streaming. This allows them to focus on their business logic and not reinvent services that already exist. But it's not all roses from the start. They are in the process of migrating their application from a monolithic architecture to serverless. And that brings new challenges that the team had to overcome, especially around understanding individual roles and mindsets, and how to learn new techniques, especially around infrastructure as code and CI/CD. But much like a video game, once these techniques are conquered, the challenges unlock great benefits. So the first challenge they faced is how to manage infrastructure as code. There are many options. Some are dependent on the cloud platform you're using. Noisy Herd is based on AWS, so they decided to choose the AWS SAM framework, which allows them to use serverless specific focused abstractions where possible, while still getting the full benefits of pure cloud formation when they need it. This is a screenshot of their template, or at least the first 50 lines of it. It's long, it's a bit hard to parse initially, and yet those 602 lines of their infrastructure as code define all the infrastructure they need to run their media streaming service on AWS. Here's what their application looks like visualized, and this is a screenshot of Stackery itself. It shows a combination of managed resources and roles and a bunch of different services. And really what this is getting at is the fact that as you're adopting infrastructure as code, you're going to need some mechanisms for your different team members to be able to collaborate without having to resort to everyone diving in and rereading hundreds or thousands of lines of infrastructure as code. So as you are adopting modern application development practices, using managed services or microservice approaches, make sure that you have some tools to help you map from the raw infrastructure as code to the resources and all the relationships between them. Let's look at some of the further challenges that the Noisy Herd team faced while they were building out their application. One classic challenge is isolation of infrastructure. Ideally, you're going to want environments separated: development, staging, production. Not only is this a best practice just to help you develop and deploy faster, it's also required by many different frameworks like SOC 2 compliance, or HIPAA compliance, or PCI compliance for processing financial transactions. In our case, our Noisy Herd team has 10 engineers on a couple of small teams. They have a production AWS account that holds their production version of the application. Thankfully, they're a bit ahead of the game. They have separate AWS accounts that they can use for development and staging. So for testing new changes, they've got their staging account once those changes have been merged into their main branch of development. And they're going to need this development environment as they work on rapid iteration of their solution. Each of these environments, thankfully, as I mentioned, are running on their own AWS accounts. But even further, it's a good practice to namespace your environments and all the resources within these accounts. This can help you if you find yourself in a situation where maybe you want each of your engineers to have their own environment, but have it within the same AWS account. So once we start talking about environments, one of the key aspects of environments is how do you store parameters and secrets? For things like a database password, you're going to need to be able to programmatically access storage for where the database credentials are. So in AWS terms, we might use the Secrets Manager service. And our compute resources are going to need to be able to access Secrets Manager. And they're going to want to access the right secrets for the environment that a given application has been deployed into. To achieve that, we're going to use namespacing so that no matter whether we're provisioning this into shared AWS accounts or independent AWS accounts, we're only going to get the right credentials for the right environment every time that we deploy our changes into it. So here we see we have our development environment database credentials stored into a secret in /dev/database password. Similarly, we have a separate location for our staging password and our production password. So we can isolate our secrets this way. We also want to isolate or make it easy for our applications to access the different resources that they need, like DynamoDB tables or different service APIs, dependent on which environment that they're deployed into. Something like this, where every environment has a separate DynamoDB table and API that it might interact with. And so here, we would want to store these inside of a location for parameters. So in AWS, we might store these in AWS Systems Manager Parameter Store. And then inside of our infrastructure as code templates, we can reference those parameters and provide the values of those parameters as values for environment variables in our compute resources. And then our compute resources can easily access the right location for an API or for a DynamoDB table by simply getting the right environment variable from its process. So now we've got staging, production, and we've talked about how we can isolate different environments using namespacing, even if they're in the same AWS account, which starts to open up the possibility of having, say, different environments for each of your team members. So here we can have, 10 different development environments alongside our staging and production environment. Now we start to wonder about, okay, so how do our developers iterate on the application? And there, especially in a serverless world, lots of folks start to wonder, how do you do local development? Because these functions that you might be running, they run inside of Lambda functions in the cloud. That's not that easy of an environment to replicate. Some people have tried different approaches, like running fake versions of all of your services that you might need, like S3, SNS, DynamoDB, RDS on your laptop. But that tends to be a bit challenging unless your laptop has 128 gigabytes and 64 cores of CPU available. And my laptop simply doesn't. So what other solutions do we have? Well, the first is that we can mock resources out so that every time we might want to access them, we provide pre-canned responses back. This can be a quick way to develop your code, but it tends to be a flawed approach because as your usage of a service increases, your mocks are likewise going to have to increase. And that tends to slow down development. You also tend to miss crucial parts as well, like having correct roles and permissions for your resources, because mocking often doesn't check for that. You can deploy with every change, but unfortunately, while that can preserve the integrity of checking for, say, IAM roles and permissions and ensuring that everything works throughout the entire stack, now it takes at least, at a minimum, 2 to 3 minutes to deploy. A couple of minutes isn't much, but when you're trying to rapidly iterate, it breaks your focus and starts to slow things down greatly overall. So the best serverless teams have adopted approaches like what we've termed cloud local. So with cloud local development approaches, each developer can run a local version of their function code, their business logic, inside of, say, a Docker container that mimics the Lambda runtime environment. But it's set up to access the real separate infrastructure in your AWS account. So your application may have a DynamoDB table, an SNS topic, and an SQS queue. If you set up your local environment right, you can run your source code locally. In the blink of an eye, when you make changes to your code, it can be rerun and tell you exactly what happens due to your changes within seconds, while using proper AWS IAM credentials that your function would have in a real-world environment to interact with the real DynamoDB service, the real SNS service, the real SQS service in AWS. And this is all made possible when you have the right tooling to fetch new IAM temporary role credentials for your function, pull it down and inject it into the environment of your Lambda functions as they run locally inside of a Docker container. So there's different tooling available to make this work. And if you're using Stackery, our CLI can do this for you. But this is probably the best and fastest way to do iterative development in a serverless fashion. So what does this look like in practice, and how does this tie back to infrastructure as code practices? So in real life, let's imagine we're a noisy herd engineer. We've been tasked with writing new functionality that allows for users to log in and comment on a live stream. Well, first, I'm going to check out the latest version of my code base from Git. And this includes both my function code and my infrastructure as code template. I'm next going to add the infrastructures I need to the template. For example, here I might add an authentication resource like a Cognito user pool and an SQSQ to queue messages. I'm then going to deploy this new infrastructure to my development environment, which is my own sandbox for playing in as I rapidly iterate. So I'm going to have a new Cognito user pool and a new SQSQ. Now I'm going to make code changes to my function on my machine, on my laptop. And then I'm going to use CLI tools to run that code locally, but using IAM credentials that the CLI tools generate that match the credentials that they would have in the dev environment of my infrastructure, to rapidly iterate and still talk to my Cognito user pool and my SQSQ that I provisioned. Once everything is working locally, I can PR the code and the infrastructure and get it ready to go through the rest of the CI/CD process. So we kind of glossed over this a little bit earlier when we talked about continuous integration. We used the example of linting, which is a very common technique to check for syntax errors. But while you can do that, and you can also use unit tests, which are great, what about when you want to test the entire system as part of your CI process, your continuous integration? Well, just as we needed to deploy out for iterative development to our development environment first, we similarly need to do the same thing anytime we want to do testing, including automated testing as part of a pipeline. So to do this, we need to augment this continuous integration part of our pipeline to not only be able to run tests, but also to be able to provision infrastructure beforehand. So Noisy Herd adopted an approach where whenever an engineer opens a pull request in a Git repository, the CI process automatically kicks off a new sandbox deployment of the infrastructure as code template in that PR. This gives a nice new clean environment for testing purposes. So that deploys out, and then once that deployment completes, now they descend into every source code directory for, say, their Lambda functions. And they run tests, npm test or PyTest or .NET test, to test each function. And those tests, they can include unit tests, but they also now can expand and include tests that validate, say, when an API request is received, that a record is saved into a DynamoDB table. And that when a different API request is received, the record is retrieved from that API, from that DynamoDB table and sent back in a response from the API. So having this amount of automation, not only around testing, but also around deploying into isolated sandboxed environments, gives you the full realization of continuous integration testing for modern applications. So as we are working on modernizing our approaches to CI/CD, this gives us a bunch of benefits. It means that we can feel more confident in deploying at any time, even for small bug fixes, even for fixes that include infrastructure changes, and truly be completely continuous in our integration and our deployment processes. Lastly, I want to touch on security and expand. We've been talking about DevOps a lot. Security is now collaborating in the CI/CD processes. A lot of people have started to create and use the term DevSecOps as a way of including security into these processes. So ideally, you want security built into your processes, your CI/CD, by again, ensuring you have environment isolation, as we've talked about before, ensuring that you have change management through code review processes to sanity check your implementation changes, but then augment the CI/CD process by adding tooling to automatically check on every change that, say, source code is scanned for vulnerabilities. To also check that permissions, IAM roles, are scoped and are properly written in a least privileged way. There's a lot of tools like Stelligent's CFN NAG and CloudFormation's Guard tools that can audit for unscoped permissions. And lastly, with the right approach and the proper automation through your CI/CD pipeline, you can have proper authentication scoping so that only through auditable checks and tests can things reach production, not only for source code, but for infrastructure and permissions as well. So wrapping this all up, when we try to think about the benefits that this can provide for engineering teams, it means that you can have robust local development approaches against live resources by having infrastructure as code and the right CLI tooling to generate permissions and run your code within containerized environments that mimic, say, the AWS Lambda runtime. It means devs can experiment safely. We have isolated environments for staging and production. We can have isolated environments for development. We can have many isolated environments for development because they're super easy now to provision and manage. It means that as we are developing our application, automated testing and deployments means less time doing menial tasks that can be scripted and more time building features. We've lowered our time to release through all of this automation, so you can move faster and users see feature requests and bug fixes sooner. And we know through our audit checks that we've got safe and secure applications for our users. Everyone is going to feel more confident that the applications that are shipped are going to be safe and secure. So that is what I wanted to kind of walk through today about how everyone who's adopting serverless infrastructure as code, our customers at Stackery, how they're achieving all of these benefits. We put this presentation together to share our knowledge, but a lot of this is stuff that you don't really want to spend your time building out just the core, foundations for. You want to take things off the shelf so you can get to the business of building out your apps faster. And so if you're embarking on new projects, modernizations of existing projects, you're looking for ways to modernize them or build them serverlessly, I'd really love to hear from you. You could reach out to us. We have some phenomenal tools at Stackery to help you get started. And you could do so with free tier developer level stuff just to play around. So again, thanks, and please reach out to us. We'd love to chat with you about what you've done, what you've accomplished as you built out your applications.
Awesome. Thank you
Ken,
so much for sharing.
Any questions come in from folks watching?
I'm going to give the attendees an opportunity to ask any questions, and I'm going to hit you with one myself. So you use the example of a startup adopting, some of these new best practices and technologies you were outlining throughout your presentation, which is a great way to kind of show them off. But we know that a lot of large enterprises.
I hope Ken is still connected.
Yeah, can you hear me? I can hear you just fine. I hope you can hear me. Attendees, if you can hear me, let me know. I just switched my mic. Can you hear me, Chase?
Looks like there may be some technical difficulties, but again, I really want to thank Ken and all the crew at vBrownBag for giving this opportunity to me to kind of present how people are building and delivering modern applications and doing so collaboratively across teams. So thanks again, and I look forward to hearing how people are building amazing applications.
Thanks very much, Chase. I'm going to go ahead and hit stop recording, and maybe the technical difficulties will clear up after.